Okay, so here we've got a very interesting probability exam question. It's about Robin who's firing arrows at a target. Okay, so Robin Hood, I guess, firing arrows. It should be shooting, shouldn't it? Shooting arrows at a target. It's a fairly straightforward, quite easy to answer question, except that it's got this rather strange beginning. It says the probability that he hits the target on his xth attempt is x plus 2 over x plus 3, which you don't usually get this kind of algebra at the start. It gives an example. It says, for example, a probability he hits on his fifth attempt is going to be 7/8, and that makes sense because 5 add 2 is 7 and 5 add 3 is 8. But it helps if you understand what this is. I think the best way of thinking about it is a term-to-term rule. So basically you've got a sequence. On his first attempt, what will the probability be? Well, it will be 1 plus 2 and 1 plus 3, in other words 3/4. So you'll have a sequence of numbers. First attempt will be 3/4, second attempt will be 4/5, third attempt will be 5/6, fourth attempt would be 6/7, and the fifth attempt, as we've seen here, is 7/8, and so it would go on. If you think about his, let's think, his 97th attempt, his 97th attempt would be, you add 3, so you've got to add 100, so it would be 99 out of 100, so it would be 99%. So it's almost, you know, it's almost certain he's going to hit it on his 97th attempt. What happens here is it goes from 75% to almost 100%. It approaches but never reaches 100%. So you've got this increased probability as he takes more shots at the target. So it's a nice little formula that gives us this increased, he gets better and better, in other words, as the tournament goes on. Okay, so that's the rather unusual beginning that we get to this question, and maybe it threw a few people, but let's have a look. Let's check the examiner's remarks. Okay, so the examiners say that part A, in fact, was quite well answered. Although many students attempted to add the two probabilities instead of multiplying them. But apart from that, it was quite well answered. So part A wasn't such a problem. Part B, however, was usually skipped. It was the least attempted question on the paper. And only a minority of students were successful in answering it, getting the right answer. Many who gave correct answers to part A really stuck when it came to part B. So they made little progress, usually because they were unable to interpret this. Hits the target exactly once in his first two attempts. So here we go. Work out the probability that he hits the target exactly once. Exactly, in bold, exactly once in his first two attempts. They didn't know what that meant. At least that's the explanation that the examiners have given in their remarks. So we'll look at that very carefully, but first of all, let's tackle part A. So in part A, it says work out the probability that he hits the target with both his first and his second attempts. Now, questions like this are best answered by a quick sketch of the branches of a probability tree. So we've got two attempts, so it bifurcates once like that, and then we can use this tree to put our percentages in. So hit or miss on the first attempt, well, 3/4 or 3/4 possibility that he will hit, therefore a 1/4 opportunity that he will miss. So 3 in 4 or 1 in 4. And on the second attempt, as we've seen, it's 4/5 that he will hit, or 4 in 5, and therefore 1 in 5 that he will miss. And the other branches depend on whether he missed. Well, it doesn't matter. It's independent probability. So whether he hit or he missed, the probabilities are going to stay the same. So again, we've got 4/5 and 1/5. So quickly sketch in that probability tree diagram, and then the answer should be visually obvious and pretty straightforward. So now let's answer the question. Work out the probability that he hits the target with both his first and his second attempt. Well, let's just use a different colour here to have a look. What we've got to do here is find an event where it's a combined event, it's combined probability. Work out the probability that hits the target with both his first and his second attempt. So we've got to have a hit on the first event and the second event. So now the hit here means we can only go down this part of our probability tree diagram, and we need a second hit here. So in other words, 2 hits. So it's only this branch that we need to consider. So tick that one. And now we simply multiply across the diagram. So always multiplication, not addition. Addition when you're going up and down the diagram, but when you're going across, then you're always multiplying. So 3 times 4 is 3 times 4 is 12 as the numerator, and 4 times 5 is 20. So 12 20ths, and you can simplify that if you want very quickly. If we divide by 4, we'll end up with 3/5. So 3/5. But 12 20ths would have been fine. So part B, the one that people found very difficult and that most people skipped. Okay, in part B, it says work out the probability that he hits the target exactly once on his first 2 attempts. So you can see how that's sort of difficult to get your head around. Okay, hits the target exactly once. Let's go back to our diagram. And what we're basically saying is which of these branches would only give us 1 hit. Okay, so the one that we highlighted before gives us 2 hits, so that's not exactly once, that's exactly twice. So this time we're going to go back to our diagram and look for 1. So on the first attempt, if he gets a hit, then on the second attempt, to get exactly 1 hit, we've got to give him a miss. So it would be this route here. So this time it's that branch times that branch. Gives us 1 hit, exactly once. Okay? And then the other possibility, the only other possibility, is if we go down this branch here. So if we get a miss on the first shot, then on the second shot we have to get a hit. So now we've got a miss, but now we've got a hit, so that's exactly 1. And the miss branch here, of course, wouldn't give us 1, it would give us 0 hits. So we've got these 2 branches that we need to multiply together. So that's how to interpret that bit of that phrase there, that bit of verbal explanation. It's the probability that he hits the target exactly once on his first 2 attempts. It basically means his probability tree diagram, we're looking for 1 exactly, only 1, and that's these 2 branches here. Now it's just a case of gathering up the probabilities. So we've got 3/4 times 1/5. Let's put those in brackets. Plus, because we've got these branches and we've got this branches, when you're going down, you're adding those together. When you're going across, you're multiplying. But we're going down here now, so we're adding. So we add 1/4, and then along the branch, times 4/5. Like that. So now we need to simplify the brackets. So we've got, let's write it here, 3 times 1, 3. 4 times 5, 20, plus 1 times 4, 4, and 4 times 5, 20. So they're both 20ths, so very easy to add. Good job we didn't use the simplified fraction, so very easy to add. So now we've got 3 plus 4 equals 7 20ths, and that should give us the full 7 marks.